Hi folks, this is Mr. Ryan, and this is lesson 5.1 in the 9th grade math summer session. And what we're going to do in this lesson is a couple things. We're going to review how to solve a linear equation, and we're also going to learn how to simplify an expression that has exponents in it. Let's just go ahead and do it, and we'll see what I mean by that as we're doing it, okay? So the first thing that I want to do here is I want to review how to solve a linear equation. Let's do a simple one. If I told you that 7x plus 5 was equal to 19, this is a linear equation. It's about the simplest kind of equation that anyone can solve. It doesn't have to have one x. Like, there can be multiple x's. But it's always x to the first power. All of the x's are x to the first power. Now, I want to remind you that when we have x to the first power, okay, that's kind of like saying 3 to the first power. 3 to the first power is just 3, right? 8 to the first power is just 8. Why? Well, because 8 to the first power means that there's 1 8. Okay, 1 8 being multiplied, so the answer is 8. Well, x to the first power means that there's only one x being multiplied, and therefore it's just x. Okay, and so when it's x to the first power, we just do not write the first power. Okay, now we've already seen quadratics, and so we know that we can have x to the second power, but all I'm doing here is reviewing x to the first power. So let's say we just have 7x plus 5 equals 19. I hope that you know how to solve this. So what we would typically do here is we would subtract 5 from both sides. We've already done a couple of these. I'm just reminding you. So positive 5 minus 5, that equals 0. And so we call that canceling. Sometimes we just slash it out. When we cancel something, then we carry down the part that we didn't change. So we carry down the 7x, we carry down the equal sign, and now what we're going to do is 19 minus 5. And so what is 19 minus 5? Okay, well, 9 minus 5 is 4, and 1 minus 0 is 1, so that's 14. Okay, so 7x equals 14. Okay, and now we're going to divide by 7, and whatever we do to one side, we have to do to the other side. Just like up here, we did minus 5 here, and we did minus 5 here. We've got to do the exact same thing to both sides. And here, 7x divided by 7, well, 7 divided by 7 is 1. And so this is the same thing as saying 1x, because 7 divided by 7 is 1. But just like with the power of 1, when this number in front, by the way, this number in front of the x, in case you didn't know this language, it's called the coefficient. Okay? So it's called a that's an E. It's called the coefficient, okay? So the coefficient of 8x is 8, okay? The coefficient of 4x is 4. The coefficient of x is 1. The coefficient of negative x is negative 1, okay? The coefficient of negative 5x is negative 5. It's the number part being multiplied in front of the variable, okay? So that's the coefficient, just reviewing our definitions and the language that we use in mathematics. All right, so when the coefficient of x is 1, then we just don't write it. We just leave it as x, okay? All right, so we canceled, and that's usually what we're doing, is we're trying to get it to where it's just x by itself. And then here, 14 divided by 7, so 14 over 7 means the same thing as 14 divided by 7. And how many times does 7 go into 14? It goes in twice, so 14 divided by 7 is 2, okay? So up here in this equation, 7x plus 5 equals 19, we can say that x is equal to 2, and we can prove it. We can rewrite this as 7 times 2 plus 5 is equal to 19. 7 times 2 is 14. 14 plus 5 is indeed equal to 19. For example, we're going to solve what is 3x minus 17 is equal to x minus 35. All right, so here's what we have. When we have, this is called a constant, a term that does not have a variable in it, doesn't have a letter. We just call it a constant. All constants are like terms. They all belong together, okay? And then here, this 3x to the first power, which is just 3x, it's very similar to this x. This x is actually 1x. And so what we want to do is we want to put everything that has an x on the same side of the equal sign. And all the constants we want to put on the other side of the equal sign. And so let me show you how I'm going to do that. And I usually like to leave whichever x has a larger coefficient stays. It's going to stay where it is, okay? So what I'm going to do here is I'm going to subtract x over here, and then I'm going to subtract x over here, okay? And what that's going to do is over here it's going to cancel the x, and I wind up with 3x minus x minus 17 is equal to negative 35. Now what I'm going to do is the constant, so I have all my x's over here, now I want to have all my constants over here. So I want to move this negative 17 over here. The way I get rid of a negative 17, this is called the inverse operation, okay? So the inverse of negative 17 is plus 17. So if we add 17, so plus 17, negative 17 plus 17 equals 0. So I'm then going to add 17 over here. Over here, this is going to cancel because negative 17 plus 17 equals 0, okay? And now I'm going to wind up with 3x minus x is equal to negative 35 plus 17, okay? Now, I want you to know that this negative 35 plus 17 can be rewritten as 17 minus 35. You can rearrange the terms in an expression as long as you bring the sign with whatever's rearranging. The 35 can go over to this side of the 17 as long as it carries the negative with it. We could do the same thing over here. If we wanted to, we could write 3x minus x as, that's the same thing as negative x plus 3x. You can see we moved the x over here, but we carried its sign with it. As long as the sign goes with it, you can move it around, okay? Here now we have, we're going to leave it as 3x minus, 3x minus x. Now, 3x minus x, this is the same thing as 3 minus 1, 3x minus 1x. And so 3 minus 1, that's all we're going to do. Ignore the x. Just do 3 minus 1. 3 minus 1 is 2. And so this becomes 2x. And then 17 minus 35, that's negative 18. Now, if you're not sure about negative numbers, you can always try it in the NumWorks calculator. We can come here and hit OK, and we can do 17 minus 35, and sure enough, there it is, negative 18. Okay. All right. I know I'm going real slow here, but we're going to speed things up in a couple minutes. All right. So now we're going to divide by 2, cancel the 2 over here, and we wind up with x is equal to whatever negative 18 divided by 2 is. Well, that's negative 9. If you're not sure about negative 18 divided by 2, then go to the calculator. Negative 18 divided by 2 is negative 9. Okay? So I don't mind you using the calculator, at least right now, because we're going so fast through this class. Okay? But in 10th grade math, we're gonna lay aside the calculator a little more. We're gonna try more and rely on our mental ability for math. Okay. All right. Let's try another example. All we're doing here is reviewing how to solve linear equations. It's something that you should have learned probably around maybe 6th grade or something like that. Maybe 7th grade. And all we're doing is reviewing it. Okay, so maybe you should try this one on your own. Let's do 4x minus 29 is equal to 7x plus 4. Okay, and so remember, we're going to try and move the x terms to one side of the equal sign and the constants to the other side of the equal sign. Go ahead and pause it and try this on your own. All right, so what we're going to do is here, We're going to leave the 7x over here. To move this 4x over to the other side, I'm going to have to do minus 4x on both sides. So I'm going to go minus 4x over here on the right. Then, to move this plus 4 over to the other side, I have to do minus 4. And because I have to do minus 4 there, I'll bring down the minus 29 and then minus 4. And so what I've done is, I've moved this plus 4 over to here as a minus 4. I've moved this plus 4x over here as a minus 4x, okay? Because I had to minus 4x from both sides. And so now, this 7x minus 4x is 3x, okay? Negative 29 minus 4 is negative 33, okay? You can check that in the calculator if you want. Now we're going to divide by 3, cancel the 3, and all we have left is x equals negative 33 divided by 3 is negative 11, and that is our answer. Now this looks backwards. We can change this now to x equals negative 11. We can switch it around. That's legal, okay? All right, so let's maybe try one more example of a linear equation. You can probably guess that in one of the lessons coming up, lesson 5.2, we're going to do a lot of solving linear equations, okay? That's why I'm reviewing this with you. All right, let's do this last one, and then we'll move on to the bulk of today's lesson. Not the bulk, but like the main point of today's lesson. Okay, so we've got 12x minus 11 is equal to 5x plus 3. Okay. All right, now I'm going to do this a little more traditionally. What I'm going to do is I'm going to minus 5x here and minus 5x here. Okay, then I'm going to add 11 here and add 11 here. Over here, it's going to cancel the 5x. Over here, it's going to cancel the negative 11. I'm going to carry down 12x minus 5x is 7x, and that's equal to 3 plus 11 is 14. Then we divide by 7, cancel, and again, x is equal to 2. I know we did one that looks very similar to this a few minutes ago. I'm going to use this style on the one that we did previously. I'm going to just review it one more time where we did 4x minus 29 is equal to 7x plus 4. All right, and so what I'm going to do is I'm going to minus 4x here, minus 4x here, then I'm going to minus 4 here, and minus 4 here. Okay, so over on the left, we're canceling the x, and over on the right, we're canceling the constant. So then on one side of the equation, negative 29 minus 4 is negative 33, and 7x minus 4x is 3x, divide by 3, and we get negative 11 is equal to, this cancels, is equal to x, or x is equal to negative 11. Okay, so we're going to review how to simplify exponential expressions, and then we're going to make it a little more complicated. What I want to remind you is this: if we have 2 to the 3rd power and we multiply it by 2 to the 2nd power, now here's the key. The base is the same. This is called the base of the exponent. This is called the exponent. The base of the exponent, the exponent. The base of the exponent, this whole thing is the exponent. This is the base of the exponent, and this is the exponent. So we're going to be using these words a lot. Base of the exponent and the exponent, okay? So when we multiply 2 exponential terms that have the same base, then what we can do is we can actually take both of their exponents and we can just add them together. So 2 to the 3rd power times 2 to the 2nd power is the same thing as 2 to the 3 plus 2 power. And I can prove that to you. We know that 2 to the 3rd power is the same thing as 2 times 2 times 2, right? And then we're going to multiply that. That's this dot right here, okay? Then 2 to the 2nd power is 2 times 2. Well, what do we have here? We have 2 to the 5th power, okay, because we have 5 2's. So this is the same thing as 2 to the 5th power. And the reason we got that is because we had this intermediary step here where we do 2 to the power of 3 plus 2. We can add the exponents if the base is the same, okay? All right, so with that understanding, we can now look at stranger looking exponents like what you see over here, okay? So we have 2 to the 7x power. So the exponent is actually an algebraic term, okay? And then this is times 2 to the 3rd power. Well, we know that since they have the same base, we can add the exponents. So we can add 7x plus 3. Okay, so this is going to be the same thing as 2 to the power of 7x plus 3. And we're done. And we're done for now. That's it. We're done. Okay? We're not going to do anything else. All right, here we have a base of 3 on both of them, and so we can add. Now, this is weird up here. We have 5 times x in parentheses. Well, 5 times x is just 5x. So this now becomes 3 to the power of 5x times 3. Now, what is that? Is that negative 2? Yeah, we can have negative exponents. We can have negative numbers as exponents. So this is 3 to the negative 2. So what we're going to do is we're going to do 5x plus negative 2. Well, plus negative 2 just means minus 2. So this becomes 3 to the power of 5x minus 2. And it really is that simple. Now here we have 4 to the power of 2 times 3x. So we have to do 2 times 3x. Well, 2 times 3x is 6x because 2 times 3 is 6. And then we have times 4, but there's no exponent on this. Hang on, there is an exponent. Remember, when there is no exponent, the exponent is 1. And so this is the same thing as 4 to the power of 6x times 4 to the power of 1. And so this becomes 4 to the power of 6x plus 1. Okay? We're simplifying exponential expressions. Okay? And then we're going to do the same thing right here. Okay? We have 5 to the power of 3 times 4x. That's the same thing as 5 to the power of 12x. And then, look at this. We have 5 to the power of negative 4 times 2. Well, what's negative 4 times 2? Negative 4 times 2 is negative 8. And so this is now going to be times 5 to the negative 8. Now we have 5 to the power of 12x minus 8. Now listen to me, folks. Don't be writing 5 and then 12x minus 8. This looks like 512x minus 8. That's wrong. That's incorrect. It's very important that you develop the habit of making your bases large. It needs to be 5 and then tiny 12x minus 8. You have to get in the habit of writing things smaller and above to the right of the number. You can't just write it any way you want. And I will tell you if I don't understand. Another way you could write this if you needed to, but I really don't recommend it, is you can write 5 and then this symbol, and then in parentheses you can put 12x minus 8. Okay? This symbol means to the exponent of, and then we have to put the 12x minus 8 inside parentheses. But I really I prefer for you to write it like this. Okay, so what we're going to do here is we're going to simplify this exponential expression. Okay. Now I know what you're thinking. This is an 8. This is a 4. You say, hey, Mr. Ryan, these do not have the same base. Okay. Right. That's the lesson. In this lesson, what we're going to do is the first thing we have to do is we have to take the two bases. We have to think to ourselves. We have to reduce them into exponential terms that have the same base. Okay, so you may not know this, but you should, and you should for the future. 8 and 4 both can be rewritten with a base of 2, because 8 is the same thing as 2 to the third power. I'm not sure if you know that. You should know that. 2 to the third power is equal to 8. Also, 2 to the second power is equal to 4. So what we can do is we can replace the 8 with 2 to the third power, and we can replace the 4 with 2 to the second power. And now this is what it's going to look like. Okay, it's now going to be, I'm going to put a parenthesis, 2 to the third power to the power of 2x. Okay, and then times 2 to the second power to the third power. Now this is now going to become 2 to the power of 3 times the 2x. That's how this simplification works. When you have something here with an exponent and then there's another exponent on the outside, basically what you do is you just multiply these two exponents. And then we're going to multiply these two exponents. So we're going to have times 2 to the power of 2 times 3. Okay? And so Go ahead and erase these so that it's a little easier to see. There we go. There we go. All right. And so now, if we go back to what we just learned a few minutes ago, this is now going to be 2 to the power of 6x times 2 to the power of 6, which can now be rewritten as 2 to the power of 6x plus 6. And so this over here gets rewritten, simplified into this. That's what we're doing today. That's today's lesson. We want to learn how to rewrite this as this. Okay? All right, let's try another example. Okay, here's another one. We've got a base of 9 and a base of 27. Well, I want to remind you that 9 is the same thing as 3 squared. 27 is the same thing as 3 to the third. And so this is now going to become 3 squared, okay, to the power of x times 3 to the third to the power of negative 1, okay? And so now what we have is 3 to the power of 2 times x times 3 to the power of 3 times negative 1. And if we were to now work out those exponents, we would have 3 to the power of 2x times 3 to the power of negative 3, because 3 times negative 1 is negative 3. And now we have one base, 3, and we just do 2x minus 3, and we're done. Let's do another example. Okay, so what we have here is we have 5 to the power of 4x times 25 to the negative 7 power. And I want to remind you that 25 is the same thing as 5 squared, or 5 to the second power. This 5 does not have to be changed at all, because we're reducing the 25 into something that has the same base as what this is over here. So sometimes you don't have to change both of them. Sometimes you only have to change one of them. And so what we wind up with here is this one stays as 5 to the power of 4x times, then the 25 becomes 5 to the second power, and then it's to the power of negative 7, which now becomes 5 to the power of 4x times 5 to the second power times negative 7. Now, you don't have to do all these steps. I'm doing all these steps to help you understand, but you can skip steps if you want to, okay? And so now this becomes 5 to the power of 4x times 5. 2 times negative 7 is negative 14, and now our final answer is 5 to the power of 4x minus 14. It is essential by the end that your final answer have only one base with a single exponent on it. And in this exercise, most of the time those exponents are going to have two parts. Okay, it's going to be a binomial, a linear binomial. Okay, so x to the first power, and then it has a constant on it. Okay, let's do another example. Okay, look at this one. We've got 36 to the 5x times 6 to the 8th power. I want to remind you that 36 is the same thing as 6 squared. Okay, so we're going to replace the 36 with 6 squared. This 6 is going to stay the same. It's not going to change because it's already a base of 6. So we're going to have here 6 squared to the power of 5x, okay, times 6 to the 8th power. And so that's going to be 6 to the power of 2 times 5x times 6 to the 8th power, which is 6 to the 10x power, because 2 times 5x is 10x, times 6 to the 8th power, and now when we simplify it, it just becomes 6 to the power of 10x plus 8. Okay? All right, let's try another example. Okay, so here's another one. We've got 2 to the power of 3x times 8 to the power of 4. 2 and 8 are not the same base, and therefore one of them has to be changed. Usually, the larger one definitely has to be changed. Well, recall that 8 is the same thing as 2 to the power of 3, and so we're going to replace the 8 with a 2 to the third power. The other 2, the 2 to the 3x, that can stay as is because it's already a 2. So 2 to the power of 3x times 2 to the third power, which is 8, to the power of 4. Can't forget that exponent on the 8. So this is going to be equal to 2 to the 3x power times 2 to the third power to the power of 3 times 4. Sorry, it's to the power of 3 times 4. And 3 times 4 is 12. So this is now going to be 2 to the power of 3x times 2 to the power of 12. And now when we simplify it, it becomes 2 to the power of 3x plus 12, and we're done. Let's do just one more example. Okay, for this one, I think it would be a good idea if you pause the video and try this one on your own on paper. Okay, so let's see here. I didn't give you the hint this time, but note that 49 and 7 are related. That 49 is the same thing as 7 squared. So we know that this is going to be 7 squared, that's 49, to the power of 2x times 7 to the power of negative 3. So this is going to be 7 to the power of 2 times 2x times 7 to the negative 3. And that's going to become, that's the same thing as 7 to the power of 4x times 7 to the negative 3. And then when we simplify that, that becomes 7 to the power of 4x minus 3. And that's it, okay? All right, we're going to take this knowledge in lesson 5.2. We're going to take it just a couple steps further. And it looks like we're really learning some good stuff here with exponents.